Good evening YouTubers, and I'm Caleb, and welcome to part 3 of building my own game from scratch using JavaScript and HTML. On the previous video I demonstrated how to get some event listening going on, so we could listen to the keyboard when events and buttons were pressed, and we added in just a bit of collision on the edges of the screen, which were the easier ones to handle to create boundaries. We also created a class for the square to go into. In this lesson I wanted to add collisions between different rectangles so that we could tell whether or not one rectangle is bumping into another. First things first though, I need to make a fix to my stroke styles here. This is wrong. I meant to type in, stroke style. Oh, did I have it saved in here? No, stroke width, that's the problem. There we go, stroke width. So instead of stroke width, replacing these with line width. There we go, that's fixed up the line width problems I had going on there. I didn't notice last week this little error that I made, but I'm just fixing this now. So for collisions, I'm going to just straight up make the function hit test and start to go through the explanation of how hit test will work. First off, we need to pass it two rectangles, so we need to pass it a rectangle A and a rectangle B, and we'll be hit testing whether or not A and B are colliding. The first thing that we want to figure out, let's actually get another rectangle on the screen just to compare the two rectangles against each other. So we're going to create the other square. I'm going to name it up here, other square, and give it a x position 50, y position 250, a width of 75, a height of 100, a fill style of blue on white 4, and then over in the update function we'll tell we want the draw function. Other square dot draw context. So now we have this other square here. I'm going to move it just a bit more over to into the screen. Here we go. So now I can walk all around it if I want. And in the onHit function, the first few things I want to find out, and I think these are going to come up often, so I'm going to add these properties into the rectangle class itself. I want to find out the half width of the object and the center X position of it, the center positions and the half dimensions of it. So I'm going to add in some getters, as they call them, getters and setters. A get half width, a get half height, a get center X, and a get center Y. I'll just put these on all of these here. When we do it, normally when you ask for a variable, like if we're asking this to let that equal rect a.x, for example, we can also do rect a.x equals 5 and so on. So this is getting it, this would be setting it. Example of getting, example of setting. But in this case here, we are only providing it a get half width. We are not making a set half width, which is good for certain functions and scopes and making sure that you don't create mistakes. When we want to get the half width, we're going to return this dot width times 0.5. Again, computers do multiplication faster than they do division, so it is faster to do this dot width times 0.5 than it is to do this dot width divided by 2. It is faster doing it this way. And we're going to do the same thing on we do the same thing in the half height, and then in centerX we're going to return this dot x plus this dot half width, and we'll do the same thing on the y-axis. Return this dot y plus this dot half height to get the center x, center y. Now that we have these little variables set up inside here, we're going to use them in the hit test. First off, we want to create a variable called vx, which is going to represent the distance between these two squares, and then after that we're going to have a variable called widths, and the widths are going to be the combined half widths of A and B. So let's say, where's our thing over here? We set the width of A to 50, the main square is 50, and the other square is going to be, let's make it 80, just so that it's a even number. So 40 add 25 in this case, we'd be imagining. 40 add 25, when we add, rect A dot half width plus rect B dot half width. We will be essentially doing half widths, so that's 40 add 25, which will be a 65. The number will be about 65 between these two. Then the Vx is going to be the distance from this center X position to this center X position. So we need to do rect A dot center X minus rect B dot center X. And now what this will tell us is, what we can figure out from this is, if Vx is smaller than the widths, if Vx was smaller than the widths, then that means, there is a chance that there is a collision happening on the x-axis. I mean, it is overlapping each other. They are overlapping because the distance is smaller than the half widths combined. So there is a collision happening on this plane. That's what the math is telling us, with this distance is smaller than the two half widths. So there is a collision happening on here. What I'm going to say though is the opposite of this statement. So I'm going to say if Vx is greater than, then return. What this will do is end the hit test function here and now, because it was not even overlapping here. So there's no point in continuing this any longer. But if this was false, then this return will not happen. So we'll continue going down this, and by continuing, I mean we're going to find out the distance on the y-axis and the heights of the two half heights combined. So we're going to do center y minus center y from B, and then let heights is equal to rect A dot half height add rect B dot half height. And now if y is greater than heights, return, which is again saying now what we're saying is, if the distance between the two is smaller than the widths, then there could be a collision happening, but we don't know yet. So we're going to find out the distance on the y-axis. If the y-axis has a smaller, if the distance on the y-axis is smaller than the heights, like it is in this picture, then it means there is a collision happening here. And so if this statement will not happen if there is a collision happening. Now we get to the fun part about this. we need to find out the overlap between the two objects. And what that will look like is the width minus the Vx, and overlap y is equal to the heights, widths minus Vx, heights minus Vy. Now, there is a little problem with the way I'm wording all of this, because the distance between these, right now a minus b might look like a positive number, but what if a is over here minus b? Then this Vx is going to be a negative number, which means it will always look like it is smaller, or rather smaller than the widths over here, even if it's overlapping like right now. So what we need to do in some of these if statements is we need to change these to absolutes. So this means that even if it is even if the distance is minus 100, if we do Math.Abs on it, that minus 100 will then become just 100. So then we can test the absolute value against the width, and again on the height value as well. Math.Abs 3y, and then over here in the overlap we need to do the same thing, as we need to know just how much are we overlapping on each axis, which is fine. Now that we figured out there is an overlap, mathematically speaking, we know there is an overlap. Now we need to figure out what side is the overlap happening on, and typically speaking, sorry, itchy nose. Typically speaking, the overlap will be the smaller number between the overlap x versus the overlap y. So if the overlap x is a smaller number than the overlap y, then the collision will be happening either on the left or the right side. That's how this would look over here, by the way. So as you can see here, the overlap on the x-axis is like just a few pixels, you know, barely overlapping at all, versus on the y-axis there's a huge overlap going on here. So that is why you would presume then that the collision is happening on the left side of these two squares. So as we said here, if the x overlap is smaller than the y overlap, then the collision is happening either on the left or the right side. Else, the collision is happening either on the top or the bottom. And how do we find out if it is on the left or the right or the top or bottom? That's just simple. We've already got the Vx and the Vy's. If Vx is greater than 0, that means the distance between A and B is a positive number versus a negative number. Well, that means if Vx is a positive number, then the collision is happening on the left side of the object. And then it's just a matter of collision on left side. This is a comment. So rect A dot x needs to be plus equals the overlap. Is it plus equals? It might be a minus equals. We'll see in a sec. Else rect A dot x minus equals overlap. Is it plus equals? It is plus equals and minus equals. Okay. Okay. And for the y-axis, we're using the same principles here. So overlap x, if it's on the left or the right side, else we're using the overlap y's, because on this side, the y overlap is smaller than the x overlap, so we need to move the object on its y-axis versus its x-axis. Why? So if it's on the top side, no, this would be on the bottom side. No, it would be on the top side. I mean, honestly, I kind of keep forgetting myself which side these will be on. But we'll find out very quickly in the update functions. Let's see. Where we did collision, we're going to do hit test, main square, and other square. And here we are. All the collisions are working fine and dandy. That's good, that's good, that's good. Now, what if we wanted other types of, what's the word? What if you wanted other types of collisions to happen? Then look no further. We're going to just tidy this up. We're going to create another square, and I'm going to demonstrate to you how we can make this hit test function just a little bit better for the sake of another square dot draw context. We're going to have 3 squares on the screen then. So let's say, for example, let's turn this to purple. If you don't want this to, you want to figure out whether a hit test is happening, but you don't want it to do the collision parts, we are going to add a third argument to the hit test, which is collide. Yeah, and we're going to set that automatically to false. If collide with an exclamation mark before it, which is to mean the false. If this is if collide is equal to false, we are going to hit return. Now we're going to also hit return true, and return false, and return false. So if you remember originally what this statement was saying, if no collision is happening on the x-axis, like no collision can be happening here, mathematically speaking, then we are going to return, but we're also going to return the word false to mean that there was no collision here. If there was no collision on the y-axis, then we return false because there is no possible collision happening. But if there is a collision happening, we will now always return true, even if we do not want to run the collision test like we're doing here. So on the update function, we have hit test between main and other square set to true, and then we're going to do another hit test with the main square and another square and set that to false. We're going to wrap this up in an if statement. If hit test returns true, then the main square dot fill style will equal orange, else main square dot fill style will equal red. So now we've made this hit test function a little more fun to play around with, so we can make it separate items and stop them from overlapping each other, or we can set it so that if a collision does happen, we can run a few functions or commands on what we want to happen when they do happen. As you can see here, when these are colliding, this square is becoming an orange square. When these squares are colliding, they are just simply blocking each other like solids. I hope that this has been a somewhat reasonable explanation of how to run a collision hit test function within your programs, and this has been quite a pure mathematical one. It was quite hard to explain, even for me. I've had to rehearse this about 4 or 5 times to get it right. But I feel like this time I managed to get it out a bit cleaner than I got some of my previous demonstrations. At least hopefully soon in the future we'll be able to use this hit test function to test and create some new objects. We can create solid walls out of this, and now if I wanted I could create an enemy and test whether or not the enemy has hit the player in order to take away health points from the player. Or I can create a key and test to pick up the key and use it to hit a door later or go to a goalpost. The amount of possibilities for the amount of events and things that can now happen is a lot, like, has been opened up, to say the least. Things have opened up for us. In the next video, I'm going to take a step back from the collision and event stuff, and I'm going to start working on building up a display library so that we have a much easier time and have to put in a lot less work to draw all of the sprites to the screen. Because at the moment, every time I want to create a new object, I have to create a new rectangle here, then I have to go into the draw square function and ask for every square to be drawn. I'm going to change that up a bit in the next video, so look out for it in part 4, which might be tomorrow. Ciao for now, guys. I hope you enjoy.